Before we define functions, we first need to define something called a relation. So a relation is a mathematical thing where you decide on a relationship between between a set of ordered pairs. So an ordered pair is something very specific in math. It means that the order of the things that you paired really matters. So if I write 5 and then 10, it matters instead of writing 10 and 5. So the order matters, and this type of order pair, so what I'm doing is I'm defining a relationship between 5 and 10, between 1 and 20, between 3 and 22. Now, there could be a mathematical relationship between them, or it could just be a relation that we're doing. We do call the domain the first part of that ordered pair, and we call the range the second part of this ordered pair. So pair means they come in twos. You might have seen this before as coordinates, for example. So we write coordinates as x and y, and for example 5 and 10. So x could be 5 and y could be 10. And it matters because 10 and 5 is not the same. So the order of them matters. So a relation is just a relationship between any two numbers that you define here. Now you can create as many relations as you want, as you could have as many, come up with random ones if you want to, but there are special type of relations, like imagine this big group of thing being all the possible relations you could create. It will be a big group. And a tiny section of those, not tiny section, but a section of that will be called functions. So a special type of relation is a function. So a function is a special type of relation, and it has these two specific properties, is that a function is a one-to-one mapping or a many-to-one mapping. So what does that mean? It means that each input goes to one unique output. Okay, so for every one input you have, you're getting one output there. And many-to-one means that many inputs can go to the same output. Okay, a one-to-one relation is quite clear. So an example of this could be something like 1 goes to 3, and then maybe 3 goes to 5, 5 goes to 7, and so on. So this could be like a one-to-one. Every number goes to a unique output. And many-to-one, an example of that, the easiest one I use to remember is x squared, because I could have 1 and -1 both going to 1, and I can have 2 and -2 both going to 4. So I can have many inputs going to one output. So that's what's happening. You get one output from many inputs, and you are allowed to have that. So every time you're confused what functions can be, it's a one-to-one mapping, and it's a many-to-one. And if you forget the many-to-one, just remember x squared, that you have many inputs going to the same output. Which leaves what's not allowed to be a function. So what is not a function in this case would be a one-to-many. And I'll show an example of that. So one-to-many is when you have one input going to many outputs. That will not be a function. So if you can show that an expression has a one-to-many type of relationship, then you can say it's not a function. This is an example of what the mapping would look like. So a one-to-one mapping, you have like a direct relation here, and many-to-one, it could be many numbers going to one output. One way to test if something is a function is by using what we call the vertical line test. So what you do is you draw a vertical line through your graph, and it should touch your curve only once. If the vertical line touches once, then it's a function. If it does not satisfy this condition, then it's not a function. And this should apply everywhere on your function, on your graph. So if I do it here, if I do it here, it's all good. I could say that this is a function based on what we did. And I could say that this is a function. And if I draw a line here, just on the edge of the circle, it does touch my graph once, but remember it has to satisfy this everywhere. So if I just do another one here, it's going to touch my graph twice. So one here and one here, so it's not a function. Now, why are we using the vertical line test? Just to talk about the mathematics here. Because if I draw a vertical line, it tells me what output do I have from that specific input. So look at this line that I drew. It tells me the outputs for -1. -1 has two outputs, here and here. So this is where you can test that your vertical line, whether it touches 1 point or more than 1 point. If I draw a straight line here, I want to see what outputs does 10 have. So I'm just going to draw a line through 10 and see how many outputs does 10 have. And 10 only has one output, so we're good. And then same thing here. I'm going to draw a straight line here through -2, for example. I want to see how many outputs does -2 have, and it only has one output. But in these cases, you have two outputs. So a quick example of something that is not a function. So what is not a function is something like a square root of x. Okay, let's say this is y equals square root of x. And the reason it's not a function is if my input was 4, then mathematically my output is a plus -2. So automatically for one input I'm getting two outputs, so I'm getting a one-to-many, which is not allowed. So a square root is a typical example of something that's not a function. So that's a good thing to remember, keep on the side. If my function is restricted, for example, positive, like it has to be positive, or it tells you that the output has to be positive, then yeah, it could be defined as a function, but that's something for later when you do domain and range. Now, this is a more formal definition of functions as well. A relationship between two sets. Each element of the first set relates to one and only one element of the second set. It means that it can't go to two outputs. So this is the function notation we use, either f of x. We could also use something like f to a colon, and then x goes to -3x squared minus 1. That's another type of notation you could use. And basically what it tells you is if my input is x, then you take the input, you square it, you times it by -3, and then you take away 1. So try to think of functions as inputs and outputs rather than just substitution. Input, output, input, output. We can use different letters. F could be G, H, K, whatever. Even the X could be different letters. So these are direct substitutions. Just be careful with brackets. So for example, for the first one, you need to make sure that you are doing -3 brackets -1 squared minus 1. And if you write this correctly on your calculator, then it should give you a -4. And then you can continue for the rest. You can pause the video and try it on your own. The second one, f of 0 is going to be -1. That's how we pronounce these, f of 0. And f of 100 is going to be 3,000 -30,000 and 1. Now for part D, you have f of a. So remember, this is your input. What is happening to your input? You're basically just substituting it instead of x. A squared minus 1. It can't be simplified any further. So now what about part E? Again, think input. My input now is x plus 1. So instead, and what's happening to my input? My input is being squared here. So for this one, you're just going to substitute in. You're going to substitute in the x plus 1 squared. So precisely wherever your input is, you're going to place it there. So you're just the x is your input here. This is what's happening to your input, and you're going to do the same thing. Now, expanding this out, make sure that you expand properly. This is x squared plus 2x plus 1 minus 1. Keep it in brackets because you need to multiply this out. So you get a negative 3x squared minus 6x minus 3 minus 1. Simplify it further. You can only simplify the last two terms, so you're left with negative 3x squared minus 6x minus 4. Hopefully this was clear. This is basically just a quick recap on definition of functions, what is a function, what is not a function, and then how to use functions as well.